Welcome back, the few proud accelerated precalculusers. Today we're going to work on section 9.4, finally using all these blasted identities we've been learning over the past weeks and months. So using them to do what? Your chapter title doesn't really tell you, your section title, but what we're going to be doing is we're going to be using them to solve equations. What else? And really the examples in this section are pretty good, and I'd like to work through a bunch of them with you. Example 1, well, what we have here is we have cosine of x mixed with cosine of 2x. I think maybe the first and most important skill in this section is just trying to figure out which identity or identities to use. So look at that for a minute and think about what comes to mind. Of all the identities we've talked about, the addition and subtraction, the double and half angle identities, product to sum, etc., which one comes to mind? Right, well, it's got to be the double angle, right? There's a cosine x and there's a cosine 2x. So if we use the identity I've bracketed in red here, we can change the cosine 2x into 2 cos squared of x minus 1. And working that out, we end up with a quadratic where the variable in the quadratic is cosine of x. So we no longer have cosine of 2x, we have cosine of x and cosine of x squared. So this quadratic can be factored, as I show here, and each of these factors can be set equal to 0. One of them yields the solution inverse cosine of 2/3, which is 0.841, and since inverse cosine only gives us one value from our calculator, we have to remember that the negative of that is also a possibility, and of course plus 2 pi n. The other factor yields that x would be the inverse cosine of negative 3/2, but we know that that's not going to give us any answers because the cosine of an angle can't be outside of from -1 to 1, and so this branch of our solution doesn't yield us anything. Alright, so that's example 1. Take a look at example 2. Which identity comes to mind? This one's a little trickier because it's kind of backwards. Right? The double angle identity for sine is really useful here because sine x cosine x is really close to 2 sine x cosine x, which is what sine of 2x is. In fact, it's half of that. And so what we can do is we can replace the left side with half of sine of 2x is equal to 1. Multiplying both sides by 2, we end up with an impossible situation. We can't find a variable that we double it, take the sine of it, and get 2. That never happens, so there's no solution. Example 3. Once again, I think something should pop into your head. Cos squared minus sine squared, that should remind you of this identity here for the double angle identity for cosine, right? So we can just replace the left side with cos of 2x. Solve by taking the inverse cosine of 1/2, remembering that that could be plus or minus, and that we can add a 2 pi n to that, and then divide both sides by 2 to get this set of answers here, plus or minus pi over 6 plus pi n. Example 4. Alright, this is kind of an odd one, but if you look at the pattern here, we have sine of something times cosine of something, plus cosine of the first times sine of the second. And so that's the addition identity for sine, as you can see here. So what it is it's the sine of 2x plus x. Our x and our y are in this case 2x and x. Well, 2x plus x is 3x, and so we find the inverse sine of both sides, and so 3x is pi over 2 plus 2 pi n. Dividing by 3, x is pi over 6 plus 2 pi over 3 n. One more example, then I think you're ready to face this stuff on your own. Okay, I think it's really obvious here which identity to use. Yeah, that's right, it's got to be the half angle identity because look, there's an x over 2, right? And here they're nice to us and they say, look, only find the solutions first 2 pi radians, as you can see here. Alright, so we're going to use this identity here in red, replacing the right side with that, then squaring both sides. Now we see that there's another identity that might be useful, and that's this Pythagorean variant here. replacing the left side with 1 minus cos squared x, multiplying both sides by 2, putting everything on the right side, factoring, and then solving each factor separately. The red factor, 2 cos x plus 1, we end up with cos x is negative 1/2. Okay, that must be in the second and third quadrants, 2 pi over 3 and 4 pi over 3. And then solving the right factor, the green factor, cos x minus 1 equals 0. Well, that means cos x equals 1, and that only happens at 0 and 2 pi. So we have these 4 solutions. Alright, so this is, they're not going to introduce any new identities on you here. They're just going to sort of reserve the right to give you problems that might require the use of any of the identities you've learned. Alright, it's not easy, but good luck. Page 608, 1 through 33 odd. Keep up the good work, guys, and I'll talk to you next time.